Hi friends, today I would like to show you how to find key features of a graph using your TI-83 or TI-84. The first thing we're going to do is we're going to go into y equals. You'll notice at the top here that we've got a series of buttons on our calculator that help us interact with graphs. And typically we start on the left and work our way to the right. So we start on the left with y equals and we can type in an equation such as 3x minus 2 times x plus 3. So we've got our quadratic in here. Um, and one of the things that we want to always keep in mind when we are putting equations into y equals is that they have to be in a y equals form where there is no y in the equals part. So this is all numbers and x's and we're good to go. So we have that. The next thing here is the window button. We can click on this window button and we can set our X min and X max and our Y min and our Y max, which can be helpful when we are trying to solve a problem, especially if we have a general idea about the area that our graph might be in. We can also guess and check these and set them and reset them as necessary, and then also interact with the zoom in and zoom out functions. Right now, I'm not going to do anything here with the window, but you can always set these and then hit zoom 0 so that the X min and X max are taking the precedence on your window, and then it'll fit the Y's to that. And I'll show you that with a specific example here in a little bit. The next thing we can look at is zoom. Zoom square and zoom standard are pretty commonly used, especially if you're doing something with a very typical, straightforward quadratic. Hitting zoom 6 will take you straight to what you're looking for. Zoom 0 is zoom fit, and that's where if you're setting your X min and X max based off of your predictions for the equation, then this will fit the Y to it, and you don't have to know the Y necessarily. Um, if you are guessing and checking on your X min, X max, you can zoom in and zoom out based off of what you get. So given the equation that we have, let's just go with zoom 6 for standard. And notice that we can't see the entire parabola. Notice that another thing is that we're not really seeing the axes. So one thing we can do is we can go to zoom format and make sure our axes are on. Right now my axes are off. So I can turn those on into a color, looking personally for gray. There we go. All right. And then we can try to get out of that, and then maybe we can zoom and do that zoom out, so zoom 3. And we still can't see the whole thing, so we can zoom 3 again and zoom out a little bit more, and we can see kind of where we're at. I don't love this particular view where we did a zoom standard and then zoomed out because it's really hard to see our units. So this is where if we go into window and we set our X min to -10 and our X max to 10, what we can do is we can do that zoom 0 to zoom fit. And I did not set that correctly. And then we can see the whole parabola and it fits it in there. So our y values aren't that standard -10 to +10 anymore. It's just really fitting it in so we can see it nicely. So that's just a little bit on how to get it to graph and to see the graph clearly. The next thing that we can do is we can look at our trace here. So if we go to second trace, it gives us a couple of options. Value is saying what is the output if we tell the calculator what the input is. So for example, if I wanted to know the y-intercept, I could click on 1 for value. On the y-intercept, x is always 0, so I can type in 0, and it will tell me that my output is -18. So that tells me that my y-intercept is 0, -18. Going back to second trace, another option here is 0, and it will tell us what our zeros are for the function. We can't really figure out the input for a specific output, With this, the value is giving us the output for a specific input, but we can find the 0. So it asks for left bound. Well, that's because there's 2 zeros in here, and even if there aren't 2 zeros, the calculator doesn't inherently know that. So what it wants us to do is to use the cursor to move our spider to the left side of our root that we're looking for. That could be really far off to the left, or it could be really close to that root. It really doesn't matter as long as we're off to the left. And then it's going to ask for a right bound, and we're just moving that spider somewhere to the right of that root. And then we could take a guess, but we don't have to. So we can just hit enter, and it will tell us that our 0 is at -30. It only tells us 1 0 at a time. So that's the left 0. If we wanted to find the right 0, we would have to do second trace 2 again. And again, it wants the left bound. It wanted the left bound, and I didn't get it for it. Now we're giving it the right bound. And since I probably screwed up the left bound, I can put my cursor really close to what I'm looking for and give it a guess. And it tells me that that next 0 is at 2 0. So our calculator so far has been able to tell us any output for a given input, specifically the y-intercept using the value. And it's also been able to tell us our 0. 3 and 4 are 2 different ways for our calculator to tell us the minimum or the maximum. So when we have the minimum or the maximum, we have to really know, is our parabola going to be with a positive amplitude or negative amplitude? So based on the equation that I gave for this, and also having looked at the graph, we know that our vertex is a minimum point because it's at the bottom of the graph. If our graph had a negative amplitude, the vertex would be at the top of the graph, and that would be a maximum. So to find the vertex for this particular graph, we're going to go with minimum. And again, it wants us to go to the left of our vertex for our left bound. Use the spider to go to the right of our vertex for our right bound. And we can move the spider to our vertex to guess if we want to. And this tells us that our vertex is at -0.5 and -18.75. Our calculator doesn't have the greatest resolution, so when it gives us this 1 on the end here, that really isn't relating to our vertex most of the time. It's not a weird decimal expansion, it should just be -0.5. And then if we go back into second trace, the last thing that we can look at for our class is intersect. We're not going to be looking at dy dx, that's our derivative, or the integral f of x dx here. Those are things that we'll save for pre-calculus and calculus. But let's take a look at intersect. That's where two lines intersect. And in Algebra 1, you maybe use that when you are solving systems of two variable equations graphically. In our class, where this can come in handy is if we're looking for the input given a specific output. So y equals, if I wanted to come in here for y equals and say, what's the input when the output is 5, for example, I can say y equals 5 because y is the output. I'm defining my output as 5. So then I can go to second trace and find the intersect. And that's going to tell me where y is equal to 5 on my graph. And there's 2 points there. It's asking for first curve. It doesn't know which line is which. It just wants to know that there are 2 different lines. So we just want the spider on our black line and then the spider on our red line. And then it's asking for a guess. And so again, we need to move our spider close to one of our answers. And this is telling us that the input is -3.313657 when the output is 5. And we could repeat that second trace intersect for the second one. Here, it's going to be harder to see our first and second curves, so we have to move the spider, first curve, second curve, and guess. We want to get closer to that other option. And we can see that when our output is 5, our endpoint is 2.3136572. So the intersect and putting a second equation into y equals is the best way to find an output for a given input. So hopefully that's been helpful and you were able to capture some notes on how to use your calculator to find key features of a graph.